Good morning, class. Today, we'll be looking at Chapter 7.2, Pythagoras' Theorem and its applications. Do fill in your notes as you follow through this video guide. We'll be looking at examples 1 and 2 today. Let's look at question 1. A water lily originally 10 cm above the water surface is blown 50 cm sideways by a strong wind to the right as shown in the picture. Find the depth of the pond. So to solve a problem like this, we will first need to understand the problem. We'll need to identify what is given. So here we know that the height of the water lily is originally 10 cm above water and the horizontal distance blown to the right is 50 cm. And what is unknown? We do not know what is the depth of the water. We also do not know what is the length of the stem of the water lily. Next, we'll need to construct a diagram using right-angled triangles because we are trying to apply our Pythagoras' theorem here. So, I'm going to draw a diagram like this. So this line here represents the water surface. So it is 10 cm above the water surface at first. And when it's blown to the right, it traveled by 50 cm. Our unknown is the depth of the water. So we'll denote it by D. If we look at the length of the stem of the water lily, even as it moves towards the right, the length of the stem remains unchanged. Therefore, we can say that this length here is actually D plus 10. Alright, so the length of this line, which is the stem of the water lily when it's vertical, is the same as this line when the water lily is blown towards the right at a slanted angle. So with this diagram here, we can now formulate our equation. So looking at our right-angled triangle, I'm looking at the triangle below. I can use the sum of squares of the two shorter sides, d square plus 50 square, to equate to the square of the hypotenuse, which is d plus 10 square. Now we want to solve this. Alright, so to solve this, remember your special products rule. So d plus 10 square will give you d square plus 20d plus 100 on the right hand side of the equation. On the left hand side, d square remains unchanged plus 50 square, which gives me 2500. We can cancel the d squares from both the left hand side and the right hand side of the equation. As I move my 100 to the left hand side, I'll have 2500 minus 100, which will equate to 20d. Therefore, 20d is equals to 2400 and d is equals to 120. Lastly, do not forget to answer the question. Therefore, 120 is the depth of the pond in cm, or you can also say it's 1.2 meters. With this, now let's look at question 2 on page 2. Here we have a cylindrical pipe, cross-section of the cylindrical pipe that has a diameter of 75 cm. The pipe is laid horizontally to carry away water. So in this case, the pink section in the picture is showing the water that it's carrying away. The question wants us to find the depth of the water if the breadth of the water surface is 60 cm. So let's look at what we are given. We know that the diameter of the pipe is 75 cm. Since we have the diameter, we can directly find the radius, which is 75 divided by 2, giving us 37.5 cm. The question also tells us that the breadth of the water surface is 60 cm. What is unknown? We are expected to find the depth of the water, so we are going to denote this unknown as d when the breadth of the water surface is 60 cm. So to construct this diagram, right, I'm going to draw two right-angled triangles here. Okay, so here I have 30. This 30 cm is actually half of the breadth. Okay, so let me show you what these two triangles really are on the diagram. Alright, so these two are the triangles that match up to each other. So this length here is my radius, and so is this length. Alright. So my radius, as I've calculated previously, I have 37.5 cm. We know that the depth is denoted by d, so we're just going to indicate it as d. And since vertically this is also the radius, I can say that the leftover short portion of this triangle is 37.5 minus d. So with this diagram, we will move on to formulating the equation. So using the right-angled triangle at the top, once again using Pythagoras' theorem, we are going to equate the sum of squares of the two shorter sides to the square of the hypotenuse. As such, I have 37.5 minus d square plus 30 square equals to 37.5 square. To solve this equation, I'll use my special product rule to expand it. Alright, so this is what I will get. And you notice that there's 1406.25 on both sides of the equation, so you can cancel both of them out. And you'll be left with this, d squared minus 75d plus 900 equals to 0. So to solve this, you have to factorize, and you should get d minus 60 times d minus 15 equals to 0. So we have d minus 60 equals to 0, or d minus 15 equals to 0, which gets us to d equals to 60 or d equals to 15. Lastly, in step 4, we want to interpret the solution. We have two possible solutions here, but when we put it back into the context of this question, we know that we have to reject d equals to 60. Alright, because d is shorter. D is supposed to be shorter than the radius. We know that this vertical line here is the radius. Therefore, d has to be shorter than that. However, d is 60, which is bigger than 37.5. Therefore, that is not possible. Hence, we know that our answer has to be d equals to 15. So answering the question, we will say that, therefore, the depth of water is 15 cm when the breadth of the water surface is 60 cm. With this, please try examples 3, 4, and 5 on page 3 of your 7.2 worksheet. You might want to draw diagrams to aid yourself. Follow the steps that we have just gone through. Thank you, class.